6 months ago, he came to my wedding, so it's like we've been really good friends for many, many years, but it was kind of my first kind of taste of, okay, how do you use computer science and these tools to build things that can actually help people? I mean, it's not pretty obvious that these tools can help people. I think we're seeing applications of this all the time, but as somebody who is very new to the field, and who had only taken classes where I'm building these kind of toy games and all of that, I think it was a great opportunity to get exposure to a completely other way of thinking. So, fast forward, I guess my senior year, I won't take this long, by the way, for all the stages of my life, but I'm just kind of trying to sketch out the foundations just so there's a little bit of context. But, my final year of college, I was really interested in education, right? So I kind of on this line of helping people. I realized education is something, obviously we hear so much about it from the Imam. So much of our faith is sort of grounded in this notion of helping people access high quality education. So I was very interested in the role that technology can play in expanding access and opportunities in education. And so I applied to, I wanted to go to graduate school to kind of study this intersection. I didn't want to go work in tech. I had done that for a couple of summers, and I wasn't very excited about trying to kind of taking a traditional path in tech, and so or consumer tech. And I wanted to go to graduate school, but I didn't want to pay for graduate school, which is probably something a lot of people here would agree is not a fun thing to do. So I ended up applying for some scholarships, and I was fortunate to receive a Rhodes Scholarship to go to Oxford. And so I spent a couple of years in Oxford, first studying for a master's in education my first year, and then my second year I did a master's in machine learning. So I'd actually started a PhD program in Oxford, but I didn't really want to stay in Oxford for that many years, I realized. And so I started it, and I think the PhD program at Oxford was very, very traditional in the sense that kind of the metric of success, if you're familiar with kind of computer science and computer science research, the metric of success was, can your algorithm outperform the state-of-the-art algorithm, by 2 percentage points or 3 percentage points or whatever, which is like a very fruitful endeavor. I think a lot of really amazing kind of breakthroughs that impact a lot of applications have come from that kind of research. But I realized that I wasn't excited about that kind of research myself. I was interested in using machine learning powered tools and developing models and all of that, but not necessarily having my kind of metric of success be, is the benchmark of this model, X% better than the previous state of the art. And so that's sort of why I left with the master's. Meanwhile, during my time at Oxford, we've been working on this startup that Ghazala mentioned. And the point of that startup was basically to connect students who, many of whom are adult learners who are taking these massively open online courses, connect them with companies so that they can actually work on projects together. So the idea is, if you're taking a data science online course, with potentially thousands of other people, you probably want to actually have an opportunity to apply those skills to a real company, and actually develop those kind of real world skills, not just learn about this stuff in the sandbox, but actually get hands-on practice, expand your CV, et cetera. And so we built a platform that was sort of connecting these learners with companies in order to do that. And, Shukr, like, people used it, like there are some cool, use cases. I think one, actually, interesting enough, there was a stay-at-home mom who's based in India. I don't remember where in India, but she's from India. I think Calcutta, actually. So she was in India, and she, through our platform, she started working on projects, really kind of building her skills, and was able to start landing sort of consulting gigs afterwards. So she was able to start attracting sort of clients and getting back into the workforce. And so that was like an amazing kind of story for us to hear, that there was this kind of pathway that somebody was able to find through the platform in order to really get back into doing the things that she enjoyed. So that was like, it was a great experience. Alas, we thought too late about how we might make money, right? So it was a business. If you have a business, you need to know how to make money through your business. We were more interested in just kind of having people use this thing. And, we tried for a while to think about different business models, and we tested a few things out, but in the end, I don't think we committed hard enough to one particular direction, which is why kind of eventually we ended up shutting the platform down. And we weren't able to kind of sustain it. But the experience was really powerful, and I think helped me, meanwhile, as we were kind of transitioning out of that, I ended up at Khan Academy. So I think a lot of what I learned from trying to develop an education platform helped me while I was working at Khan Academy, which is obviously kind of an established online learning platform. Yeah, Khan Academy worked on a bunch of stuff, worked on tools for teachers to help them kind of teach their students math better, for them to actually see Khan Academy as a useful tool in the classroom. It's actually, most of Khan Academy's users are people who come to the platform because they want to learn a specific topic or discipline, but it's actually not set up to be necessarily a useful tool for teachers. And so we were trying to figure out how could we sort of make this thing useful for teachers. And that was also fun. But I think as I was at Khan Academy, I really missed research. And, that's something I really enjoyed at Oxford, was kind of the research piece. And so, and I actually thought about applying to the Media Lab at MIT for many years, ever since undergrad. So my plan was, if I hadn't heard back positively about these scholarships, then literally the next application that I already started was for the Media Lab. And so I had always kind of thought about applying for a while. And the reason was because the Media Lab, although right now there's not a lot of positive news about the Media Lab in the media, and we can talk about that separately if you'd be interested. But in general, the Media Lab has been a place where it kind of sits in between academic research and industry. And so the idea is to do research. It's an academic research facility, but research that you really kind of deploy into the world and you evaluate in the world. And so I think that evaluation piece, I knew I didn't want to be in a traditional program where the evaluation for computer science type research was often kind of the algorithmic performance. I think I wanted to be evaluated based on, the human impact of my work, right? And so I can talk more about this in a little bit, but the research, I think, lended itself to, you have to think about technical problems, but ultimately you're sort of deploying them to people, and then you're seeing how people use the things that you built, and then a lot of your evaluations are set up such that you're trying to get a sense from people what they thought of whatever you built and whatever you've deployed. So I was fortunate to be accepted there, and that's where I've been for the past 3 years. Yeah, it's been fun, Shukar. I feel like the past 3 years I've had a chance to, in addition to doing research, just explore disciplines that I had never explored before, I think, coming from a more of a traditional computer science background, and also start to see how, it might sound cheesy, but like how really like all of these disciplines are really connected, right? Like you don't think of art and computer science as connected, but they're connected. You don't think of social science and computer science as connected, but there's like infinite connections or possible connections between all of these sorts of fields, which is very exciting and very interesting. So I'll shut up now.
Thanks, Nabeel, for this wonderful journey, like right from the high school till now. So I'll start with a question from my end. So I and Saif are very fortunate to visit the Media Lab and have a tour with you this February. So during this visit, we saw a few things you were working on, including your study using neural networks to determine political ideologies of the people of the US. So can you explain more on this project to us?
Sure, yeah. So our lab does a lot of different things, but probably too many things, I think, but one of the things is looking at political discourse on social media. And so a few years ago, it's almost been 4 years, I guess, but a few years ago, around the time of the 2016 US presidential election in the US, where our friend who's currently president right now in the US became president, our group had a project called the Electome, and the basic idea was that a lot of people are talking about politics and related issues on social media platforms. And the question was, can we actually get a pulse on what people are talking about and who's actually doing the talking? And so our lab is actually funded by Twitter, and we have access to the full Twitter fire hose, which is just every single tweet that's produced every single day. And so the team, they built a lot of this before I got here, but the team built a set of classifiers basically to be able to start to categorize election-related discourse on Twitter. And so they first started by, they used machine learning, deep neural networks to do simple classifications like, is a given tweet about the election or not? So, imagine 500 million tweets coming in a day. You have a classifier that's first kind of tagging these tweets as if they're about the election or not. And then you have another set of classifiers that are tagging them into different election-related issues. So these were issues like guns, immigration, foreign policy, et cetera, social issues, all of that. And so from that, we're able to kind of get a sense of like a daily snapshot of what are people actually talking about? What are the relative kind of share of issues that people are discussing on Twitter? And there's some interesting things that we saw. One was that oftentimes the conversation on Twitter was different from the conversation in mainstream media. So people tended to talk about different issues. Like one week, I think the week that the vice presidential nominee was selected, I think about a third or 30% of the news in mainstream media was about that nomination, but only 3% of the discourse on Twitter was about that. And so the point there is like sometimes there's these like orders of magnitude divergence between sort of what's going on in the social kind of public sphere and what the mainstream media is talking about. And so yeah, I mean there were a couple of interesting technical problems that kind of came up with that. I won't get too deep into these, but happy to discuss more if you're interested. One is just the fact that the models were trained effectively to pick up on the linguistic patterns of what people are discussing, right? And so the thing is any sort of live conversation, the patterns are changing, right? So there's certain words that start to be about certain, like the election or politics or anything at certain points in an election cycle that weren't really politicized words before. And, the example in the US context is something like the wall, right? So here in the US, Trump started using the wall in order to talk about immigration and how we should be building a wall to sort of keep people out. Now, before he talked about that, the wall was not really something people thought about with respect to the issue of immigration. But then, of course, soon after, that became a pretty core kind of phrase that became about immigration. So the models were kind of trained to automatically discover these expanding terms and to retrain themselves, right? So every week, the models would retrain themselves in order to have sort of more up-to-date information on what kind of constitutes some of the different topics of conversation during the election. Another, like, I guess the other piece of this was really starting to look at who's actually talking. So I think this goes to your question, Ghazala. We built some classifiers basically to identify like who are the Republicans or, the conservatives, who are the liberals, who are the people who don't fit into either of those buckets, right? And what are the issues they're talking about? And so, the ways you can do that. So this is pre-Cambridge Analytica. I don't know if you guys have heard of Cambridge Analytica. All of this is very scary now, but, with Cambridge Analytica, we've seen that the signals we give off on social media are extremely powerful in describing us, right? Like we don't even realize the inferences or the predictions people can make about us based on simple things that we post, right? Or like, so our classifiers actually were using on Twitter, the text in people's profiles, right? Their social networks, like who are they connected to? We're able to actually get, are they following Fox? Are they following CNN, right? Are they following these different media outlets? So when you combine all those signals, you can actually get a pretty strong indicator of what someone's political preferences are, right? In fact, I would argue, and actually the data has shown that the social network alone tells you what someone's political preferences are, right? If you're following New York Times, CNN, and et cetera, in the US, you're more likely to be liberal. If you're following Fox News, Breitbart, you're more likely to be conservative, and that itself is like a pretty clear split. So, so we actually leveraged some of those signals in order to determine like who are these people who are actually doing the talking.
Thanks for that. So next question is also from my end. So can you tell us a bit about your journey, about your MIT research and what it entails? And so that it gives a clear idea about the path of your research field to the techies who are there on the call. So can you tell us about the path of the research field so that they get a clear idea, like how is the research actually, how the research actually happens?
Yeah.
So can you tell about your journey at the MIT to that?
Sure. I mean, I guess maybe I can just describe like, I guess a pattern in some of the research that I've worked on or that I'm interested in. So like traditional research, I think, and Chairman Khalid is more of an expert in this than me. So Chairman Khalid, please chime in from your perspective if you have any thoughts. But I think like, at a very high level, research follows a scientific method, right? So you have some kind of question or hypothesis that you want to test, and then you design some kind of study in order to evaluate that hypothesis or answer that question. So the study could be, let's say I want to know, what are the topics that Democrats or liberals on Twitter are talking about, right? Just to use the previous example, we might have a hypothesis that they're talking more about kind of welfare and sort of social issues than Republicans might be, conservatives might be talking more about war and whatever, right? That's a huge stereotype, but that might be sort of your question or hypothesis. Then you would go and collect data, to analyze the data, and then you kind of evaluate it and see, okay, like what is the answer to my question, right? Like how correct or incorrect was that my hypothesis? So a lot of times you can do that by accessing data that already exists. Sometimes you need to generate new data, so you'll run an experiment, right? So so that's actually something we ended up doing after we analyzed this election data. A couple of questions we had were, some of the things we saw were that there were these big divides, right? So if you actually looked at the social networks on Twitter of people who were talking about politics, you had liberals only really talking to liberals, you had conservatives really only talking to conservatives. They were kind of in their own echo chambers or bubbles, if you've heard some of that terminology. And so a question we had was, can we bring these people together, right? And actually one of the phrases that was really motivated me when we were thinking about this was something that it was a speech that the Imam gave at Brown in 2014, where he said something to the effect of, knowledge gaps become empathy gaps. And so he was actually referring, I think, to this kind of digital world where, we're technically more connected than ever before, but we're actually, greater connectivity does not imply greater connection, I think is what he said, right? So we're more connected, but we're still isolating ourselves in many ways from diversity, right? From people who know and believe different things. And we saw that in the data. Like, it was very clear when we saw that there are these bubbles that existed of people only talking to people like them. My question, and I tried to share this with the group, so our question sort of became, how do we bridge these knowledge gaps, and how do we bridge the underlying empathy gaps that might be forming between these different groups? And so we built some tools and we designed some experiments. So one thought was, what if we can build a tool that people can use when they're browsing Twitter to teleport themselves into the Twitter feed of somebody who has a very different political perspective than them, right? So when you're on Twitter or whatever, if you don't, any social media, the content you're seeing is kind of a reflection of your own biases and the things that you agree with. So we just built this simple extension where you could press it, you could flip your feed, and you could teleport yourself into the feed of somebody, if you're a liberal, then into a feed of a conservative or whatever else, and just kind of experience their media ecosystem for a while. And so that was interesting, right? Like for us, that was sort of the process there became, we run an experiment, but to run the experiment, we had to build some new technology. So we built some new technology, many people downloaded it, installed it, and then we were able to kind of collect data and see what happens when they're actually using this tool. Does it actually affect the way that they think about the other side? Does it affect their future behaviors, et cetera? So we built some tools like that. We built one other thing as well. Another thought was, I think a lot of us end up embedded in our own echo chambers on social media because we're just not aware of that there's a broader world out there, right? Like we don't know what we don't know, right? We don't know what we're missing out on. So we actually built a tool that would zoom people out and show them their little point in a broader social network and encourage them to see connections with people on the other side. And we saw that in some cases that actually work. People ended up forming connections with more diverse groups of people. Unfortunately, that was very short-lived. After a couple weeks or so, their sort of steady state default behavior returned. But at a high level, that was kind of another experiment that we sort of ran and collected data, and were able to kind of analyze it and write research papers, publish them in conferences, journals, et cetera. So that's kind of the research process that I think like we've taken in the lab, and that I'm interested in taking is like, having a question, but then building some technology that would allow you to actually ask that question and capture data, and then sort of evaluate those results, and then share them with the research community, but then also share them with the public at large, right? To the extent that those findings are relevant to the public. Sorry, I think you're on mute, Ghazala.
Can you hear me now?
Yes, yes. Can you hear me now?
Yeah. So, can you tell us about your experiences with working at CoreSolve, and how so that we just get to know about the entrepreneurship, as you have been a co-founder there. So
Sure. I can tell you my experiences working at a failed startup. I'm happy to. So we, I mentioned this a little bit earlier. When I don't know if everyone's familiar with these kind of massive open online courses, MOOCs. I'm sure you guys have heard of MOOCs. So this was like 2012, year of the MOOC, as the New York Times called it. We were all swept up in the MOOC hype. I think in particular, so it was actually me and another fellow Ismaili friend of mine who was based in London. So I was at Oxford, he was in London at the time. We were really good friends. And we all, believed in this idea of expanding access to knowledge to people and opportunities for reskilling and improvement and all of that. And so we were also amazed by the fact that these MOOCs were bringing together thousands of people from around the world, right, in order to kind of learn similar things. And so we thought it'd be interesting. Can we kind of harness that collective brain power in some way? Can we bring those people together, and while they're working on their coursework, can we have them, the initial idea was, can we also have them do something that produces something for a nonprofit or for an organization or something, in order to both be learning themselves by doing practical work, but then also be producing kind of artifacts or outputs that could be useful to people, right? Like a strategic plan for a nonprofit, or maybe a bit of data analysis for another nonprofit or something like that. So that was kind of the initial idea that sparked all of this. So, we piloted, we just randomly emailed professors we'd never met who were teaching MOOCs. And we were like, hey, we have this idea, do you want to work with us on it? Or can we run some tests in your online courses? So these professors were teaching on Coursera. So their courses were on Coursera, which is a popular MOOC platform. And initially, we ran pilots by just using the forums on Coursera. We didn't build any technology. All we did was we just tried to work out the kind of flow of how does a company post a problem they need help with, or an organization post a problem, how would students discover that problem, connect with that company, etc. And we kind of saw how that worked without building any technology first, because we were lazy again. You see this common theme of laziness in me. We were lazy. We didn't want to build something that nobody was going to use. And so we wanted to first learn and figure out what we need to build. And so we did that for a while. Meanwhile, I think we wrote some articles. I don't know if I would do it this way again, but we were very interested in trying to generate buzz and interest in sort of what we were doing. And so we wrote some articles and people reached out. And so we were able to start building maybe a base of people that might be initial users of this platform, either student users or companies that are sort of posting projects for students to work on. That's something, looking back, I don't know if I would do that again. I think I would focus much more on just building a really, really good product, instead of trying to, get a bunch of people to care about what we're doing before we have anything even to talk about. Sounds obvious. So all of these things sound obvious in retrospect, but for us, we were trying to figure things out as we went. But yeah, so we worked on that, and then over for a few months, there's summertime, so I had time off. We actually, funny enough, all of these paths come together, but I had heard about this new person, Sanjay Sarma, who's actually one of the founders of RFID technology. He's a professor here at MIT. He had been appointed the director of digital learning, MIT's first director of digital learning, in 2012. And I just saw a press release about it, and I just emailed him. I was just like, you seem like an interesting guy. I'm going to be back in town and visiting Boston in a couple of months. This was December of 2012. Would you have time to meet? And he actually wrote back and he agreed. So we ended up meeting, and he had offered, he was like, what can I do for you? And I just asked him, can we have some space at MIT this summer to build out the first version of our platform? And he was such a nice guy. He said yes, and he even paid me. He paid me for some reason as sort of a, I guess, a fellow or a visiting fellow or something for his department, to work on our own startup, which was pretty cool. And since then, he's been a great mentor, and he actually wrote one of my recommendations for the Media Lab. So that's sort of another example of just somebody who, went from to kind of a professional person in my life to just being a wonderful mentor and friend. But yeah, that's, we had space at MIT that summer of 2013, and we built the first version of the platform, and then we kind of launched, and it was cool. I mean, we saw things breaking. I remember at one point we had a huge influx of students, like thousands of people joined the site at the same time, and all the infrastructure broke. So I was like, I think I was at dinner. So my wife now, at the time, we were, just friends, and we were at dinner. I think I pulled my laptop out and I started like fixing the site that was crashing, because it was like people couldn't log in, and it's like we're losing users, right? The site is crashing because we haven't built this thing to scale, and it's just all these scale problems you just don't think of when you're building a prototype. And thank God she didn't leave me right there, but she wasn't exactly very happy about what I was doing. So that's another lesson learned. Even if you're working on startup, it's really important to have a work-life balance. But anyways, those are some of the stories I think from that time. And eventually, like, it was an amazing learning experience, I think, personally. And I grew so much, right, in terms of just like thinking about products and partnerships and, managing people and all of that. But again, we weren't able to kind of figure out a business model, which is sort of why we didn't end up pushing forward. But yeah, I think it's a great thing to try. I mean, I tell everybody, like, if you have, I think when you're in your 20s or whatever, it doesn't matter what age you are, but like, especially I think if you're just out of college, like, nobody's really going to remember what you did for 1 or 2 years after you graduated, right? Like, you probably won't even remember. So I think if you have an idea, if there's something you're excited about, like, there's a lot of money out there that you can get, even in grant form. You don't have to just sell a part of your company and raise equity money. Like, you can accept it in grant form and just get in-kind contributions and stuff, and just work on something, right? The best case is that it goes somewhere, and the worst case is that you learn an incredible amount that ends up completely like influencing the things that you try in the future.
That's a very good advice for us. So I think now we can open up for the questions to the audience. Guys, you can just ask questions if you have.
Hi, Nabeel. Raj here. I am an architect, basically, not a tech guy, and know very little about AI. Can you hear me?
Yeah.
Yeah. Just wanted to inquire, if, what are the applications of AI in field of architecture? Like, what is the present scenario right now? Because we are like not a bit aware. I think you are in the field, so it would be great to hear from you about it.
Yeah, that's a great question. So I am not too familiar with architecture as an application domain for AI. By the way, I'll say, like, I think this is probably, I think this might have even been in the questions. Like, AI is such an overloaded term, right? Like, we hear about it all the time. It's like everything and nothing is AI at the same time. So I think, like, one thing I just personally like to think about is more like, actually, like, if we're talking about machine learning, just saying machine learning, even though that's also an overloaded term, but at least that's closer, that's like already infinite, like so much smaller than kind of this broad space of AI, because there's all these, AI used to be around, has been around for decades, right? And all we're seeing now is kind of the recent advances in machine learning, which have been enabled by very large data sets, amazing hardware acceleration, and some innovations in algorithms. Although, even though a lot of the the core algorithms that are driving, deep learning and a lot of kind of the recent rise in machine learning have been around for decades as well. So that's my side rant on machine learning and AI, just in terms of like, don't get scared when you hear these terms. They're actually very old concepts and very old terms. And, a lot of what's the reason it's in the public discourse right now is because you have the data and the hardware to actually be able to do pretty crazy things that you couldn't do before. But at the end of the day, these machines are actually very stupid. And so that's another thing to really, I think, keep in mind as well, which is there's actually a great paper I recommend you reading. It's called Building Machines That Learn and Think Like People. And so, these machines can do amazing things, right? Like they can detect all of the cats in cat videos or whatever, else we think is like a worthwhile task these days. But what they can't do is they don't have a notion of like, what is a cat, right? Or like, what is a person? Like, how does this cat feel? Like, is this cat hungry, right? Like the machine is able to detect these things. Like if the task is cat detection, because it's just learned this extremely granular kind of understanding of how pixels need to be arranged in order for that thing to be a cat. So the brilliant machine learning systems these days are just glorified pattern recognition systems for the most part, right? And they require millions and millions of data points and able to make their predictions in most cases, right? Like, for example, you think about gameplay, there's machines that are beating StarCraft world champions, right? Or the, world champions that Go and chess, which are remarkable feats, but they require kind of playing millions of games, simulation games in their heads to really kind of learn the space of possible moves and possible outcomes to then be able to make smart decisions about what step to take next, given maybe a step or move that their opponent takes. Whereas like we as humans, we can watch somebody play a game for a few minutes, right? And we can learn how to play, which is like a pretty amazing thing, right? Like, so it's all of this always makes me like appreciate the amazing kind of like creation of the brain, right? Like the brain that God has created in us and like how intricate and nuanced it is. And even though machines now are being able to achieve pretty remarkable things, they're still missing a lot of kind of the notions of abstract thought, abstract reasoning, right? Emotional reasoning, empathy, like all of these things that sort of make us human. So anyways, that's just kind of a side kind of point on AI. I think that when you're reading the New York Times articles and stuff, you don't really see a lot of that, I think, but I think it's an interesting kind of thing to keep in mind, especially if we start to get worried about kind of how it's disrupting our fields and all of that. That being said, I mean, machine learning tools are being able to do a lot of things that humans were like seemed uniquely human over, in the past even 10 years ago. So in architecture, I actually don't know. Yeah, it's pretty disappointing right after that whole spiel. I actually don't know. But I think, one thing that I've heard of or that machines are doing is like there's been advances in generative modeling. And so, machine learning systems like a traditional a cat detection system is what's called a discriminative machine learning model. So it's learning kind of given some input data, like an image, to predict some category, right? Like, does this image have a cat in it or not? But machines can also be trained to kind of learn this sort of, I guess, sort of like enough about like what, like the label of a cat and the data in order to be able to generate sort of new images, right? So if you kind of learn the structure of the image space, if you give a machine lots of images, it can actually learn kind of this distribution over images, over all images. And if it learns that distribution over all images, then you can sample from that distribution, which means that you can actually ask that distribution for an entirely new sample or a new image that it was never actually given as a part of its training set. So this is when we talk about like deep fakes. I don't know if you've heard of the term deep fakes, but we've gotten to a point where machines can actually generate images of people that you can't even tell that they're generated by a computer because they're so fit to this kind of underlying distribution of people images that they're able to produce these things that just look extremely realistic. They're entirely new ideas, right? Or new kind of snapshots of people that they've never seen before. So you can, this idea has been extended. You have papers that are actually building models that can generate art. So what they can do is the model can take as quote unquote influence various artists. So you can kind of give it the style of Van Gogh or give it the style of this other artist, and then the machine can actually generate a new painting that was never developed actually by Van Gogh, but actually looks like it could have been created by Van Gogh because it just captures the style of Van Gogh so well. And so when you talk about architecture, I don't know if, I'm sure there's people doing this already, but just one thought that comes to mind is this whole idea of like designing spaces, or maybe designing kind of like parts of this kind of creative process of architecture, depending on sort of what it is. But in theory, if you had enough data, you could sort of give a machine, like maybe you want them to design a new floor plan or something, right? You could give, and this is how ignorant I am about architecture, but assuming that's one thing you wanted to do, you could give a machine a bunch of floor plans, and in theory, it would be able to kind of learn this distribution of floor plans and then be able to produce a brand new floor plan that it might not have ever seen in its input data before. So one application could be just designing configurations that we as humans have never seen, but that are grounded in some reality. I mean, this is where, if you've heard of drug discovery, this is, I think, where a lot of the work in drug discovery is headed. You have pharmaceutical companies that want to know how to combine different molecules in order to produce certain drugs, right? To be able to sell on the market. And so you have startups now that are building models that are learning, they're taking as input all of these kind of molecule combinations and reactions that have happened before, and they're using them to see if they can teach a model how to produce new kind of drug combinations, and then see if those drug combinations would actually fulfill the objectives that this drug has been set out to achieve. So this kind of paradigm, I think, is showing up in a lot of industries. So I wonder if there might be some applications in architecture as well.
Quite interesting. Thanks so much.
Okay, I have a question.
Mm-hmm. Hi, yeah.
Yeah, I'm Tamanna. I come from mechanical engineering background. So basically current trends like, looking at the mechanical companies like General Electric. So everyone is moving towards AI, developing digital twins and kind of technologies to monitor the systems. So, if you wish to learn AI machine learning right now, so how useful is it to learn like from edX Coursera? Like, is it sufficient to make you that, qualified maybe, or, you need to take some extra efforts if you want to excel in the field?
Yeah, I think those classes, like, I haven't taken machine learning on Coursera or edX, but I've seen some of the classes. Like, I think they're good for helping. So I think classes are always good for sequencing content. So I think in that sense, like this, even the syllabus itself is useful just to see how somebody steps through the different concepts. I think they're good for helping to show you the background that would be useful. So I really think like you don't need to know a lot of math these days to use machine learning. Like there's a lot of libraries out there. I do think it's great to like learn a little bit of linear algebra if you haven't already, and a little bit of probability and statistics and a little bit of calculus, because I think those are kind of the core of machine learning. And I think it'll just help this stuff make more sense, right? Like it'll move from being two function calls in some machine learning library or package or whatever to actually like helping to show the richness underneath it. So I think like the courses can be good for exposing you to some of those background pieces. Like I think the Andrew and Coursera course actually has like a linear algebra tutorial or something like that, right? So I think those kinds of things are useful. Yeah, and I think kind of teaching the basics of like, every machine learning model has like some kind of optimization, right? Like it's learning. The learning part is like learning the values of parameters, right? To be able to make future predictions. And that parameter learning is usually like a calculus problem, right? And so I think like the courses are good at walking you through kind of a core example of how that works. So I think that's useful. In terms of like being able to apply this stuff, I think I would definitely take one of these core classes, and then it might sound like unfulfilling, but I think working on projects is probably the best way, right? So if there's like a specific problem that you're curious about, I think the best thing is find someone else who's also curious about it and work together, because you'll actually teach each other. I think these things are like, I find it very difficult to learn this stuff on my own, because at some point, like after you get past the foundations, because at some point there's all these questions about, oh, like, should I do this or this, right? And that's so often problem specific that no course is going to be able to tell you what the answer to that should be, right? Like, should I use this model or this model? You just try things out. But I think having someone who has a little experience and is interested in learning it as well is important. So that would, I'd say, at some point when you're actually trying to apply these things, I think that's a really, really important step. Yeah.
Okay, thank you.
Yeah.
Any other question, guys?
Oh, there's one here in the chat from Shalina. Should I read it? Yeah. Will AI take away jobs, or will it displace few of them? So yeah, there's a lot of people kind of thinking about this stuff. And in fact, there's another Ismaili who's actually a postdoc at MIT whose research is exactly on this, and I'm happy to connect you with her if you'd be interested, so let me know. But I believe like what people feel like right now is machine learning is already replacing a lot of like routine kind of manual, not even manual really, but routine work. So actually there's an interesting paper that talked about how machine learning is really well set up to replace almost like not really low skill necessarily, but work that requires little dexterity. So if you think about dexterity, like flexibility, agility, like that can be sort of mental agility, or that can be physical agility. So, machines are well suited to replace work that does not require that much agility, which could be like middle management in many cases, right? It could be things that are like routine and sort of like easy to kind of automate. Of course, the machines are going to be well suited for that. But it's not just a matter of skill, because, for example, we look at like housekeepers or cleaners, right? Like machines are not really replacing cleaners, because it's hard to build a robot that knows how to like navigate a desk in order to clean behind the desk, right? Like it's not necessarily a high skill job, but it's still something that's actually hard for a robot to do. And then, of course, on the other end of the spectrum, creativity, these things like we talked about, these models that are like able to generate new kind of creative examples of things, but still this core kind of human intuition of creativity and abstract thinking and all of that, machines in general are not good at that. And so I think those kinds of jobs, at least for now, seem safe. So I'm not. It's a broad question. I think it's really like they will continue to take away like many kinds of jobs, but then I think they're also extremely far from being able to take away other kinds of jobs. So I think the question is like, how do we position ourselves to kind of think about the work that really is uniquely human and kind of draws upon our unique human skill sets to do.
Hi, this is Zahir here. Can you hear me?
All right. So I have a question. Yeah. Yes, sir.
Yeah. So I'm part of the RFS national team, and I have a background in biotechnology, and I'm currently an entrepreneur in the healthcare segment. And I've always thought that there is so much potential for the use of AI and machine learning. And again, like you said, that it's a very broad term. But being in the Media Lab, are you exposed to applications of AI and machine learning in healthcare? And I know the industry is very regulated, so it takes a lot of time for it to actually come to for you to actually see it in action. But I mean, if you could just share a few examples of what are really cutting edge applications in the healthcare segment, it could really give people an idea of where it can go.
Yeah, I mean, definitely not my expertise, but I mentioned drug discovery. I think that's a really hot one right now. A lot of people are trying to figure that out. Can we use machines to help with the process of drug discovery? Because the current process is extremely manual and extremely slow, right? Like running real experiments or reactions and seeing what happens. So I think a lot of people are excited. There's actually a lot of money in the drug discovery space right now, I believe. If you're from a business standpoint, that could be very interesting. In fact, there's an Ismaili if you ever want to talk to him, a friend of mine who's starting to work on a startup in the machine learning drug discovery space. So happy to connect you if you'd be interested. So that's one. I've seen work around pain prediction. Like I just saw, there's a PhD student at the Media Lab who's trying to use machine learning to, like, I guess, look at, like, see if we can based on EEG signals or just some other signals about the body, like predict like how much pain somebody's in. So you might say, well, why don't you just ask them? Well, you could ask them too. That's definitely a reasonable approach. But I think there are certain cases probably where either you can ask them or whatever, where being able to learn that mapping between like some other signals that the body's giving off and actually how much pain somebody's in could be valuable. So that's like more of maybe a niche application, I think. There's some folks who are working similar in this prediction space. There's some people who are working on, based on various signals, can we start to predict like the possible onset of dementia, right? Like Alzheimer's, Parkinson's, et cetera. So there's quite a few people kind of working on that too. And then there's like micro applications, I think, as well. Like, a lot of that stuff is prediction. I think you also just have really micro applications like, your Fitbits, right? Like kind of getting an accurate reading on how much you have, how many steps you've taken or how much exercise you've done. Those things, there's little applications of machine learning and kind of calibrating those measurements and all of that I think are maybe even more widespread from a consumer standpoint. And there's a lot more for sure. Like, I mean, there's things, of course, like kind of radiology reports, right? Like looking at radiology reports, and Chairman Kahlo would be much better suited to talk about this than me. But, if you have like reports, well, I guess a couple things. One is like pictures. So if you have scans of the body or, CT scans or whatever, MRIs, training a model, I think they found that they now have machines that are able to assess how cancer is evolving, or even if there is cancer or not. I forgot what exactly the assessment was, but those assessments are as accurate as a radiologist's assessment. And so they're able to leverage the fact that like machines, like deep learning has really mastered this image recognition task. And now they're leveraging that ability to do image recognition and applying them to different domains, like cancer image prediction. And then there's some people, I don't know how big this has gotten, but there's some researchers at MIT who were taking pathology reports, so actually written reports with doctor's notes, and they were able to basically do a classification task. So based on what doctors wrote, like, how likely was it that this person had this pathology or this pathology, right? Or what were the different kind of parts of their body that were affected by which pathologies. So that's more of like a natural language processing task. Like you have this unstructured text that has come from doctor's notes, and you're trying to basically classify that unstructured text into some like structured database. And again, that could be something that someone manually does. Like I think that's what kind of doctor scribes would often do. But now you're having machines that can do that sort of reasonably accurately. So yeah, and then I just saw Aman's point, yes, about medical image analysis using AI, right? Yeah, so in the diagnosis sense. So yeah, there's a lot. I mean, that's probably a very small sampling. The other kind of thing I think in the AI and healthcare space, and this applies in AI and education or really anything, is like what are the implications for these technologies on equity, right? So I think there was an example. There's actually a great Quartz is a publication here in the US, a great sort of Quartz series on AI and healthcare, which I really recommend checking out. But one of the, it might have even been on AI and healthcare and ethics or something, but it gave the example of how there was a system that had been developed that based on somebody's speech patterns, the system was trying to predict if this person had Parkinson's or not, because I think Parkinson's often affects your speech. And what it found was that system was much more accurate on Canadian male voices than the voices of people from other countries and other genders. And the reason was probably because the system was actually just trained with examples primarily from Canadian males, right? And so it learned to really tune into the features of those kinds of voices at the exclusion really of other kinds of voices. And this is a general problem in machine learning. So if you have data sets that you're using to train systems and those data sets are not maybe capturing or representative of the population that you want to deploy the system on in the end, then those machines are going to pick up the nuances of those training sets and maybe not be as accurate or as useful when you're applying them to other groups of people. So that's extremely important, because in healthcare, of course, you're making often life or death kind of decisions. And if you have a model that's like biased in some way against certain groups, then you could see ourselves potentially doing a lot of harm to people.
Got it. Okay, so I think the drug discovery part that you mentioned, it also really applies towards repurposing. So if a molecule is used in a certain indication, extending that to other indications, which is something that's patentable in the US, that's primarily where we've seen it applied. So from just to summarize, so repurposing or new drug discovery, diagnostics, wearables, yeah, I think that's pretty much what you've seen, correct?
Yeah, and then I think the ethics piece kind of underlying all of this is really important.
And just one quick question. So if someone wants to collaborate and use, AI without having that kind of, background understanding, is there any way to collaborate with, institutions? Because what you mentioned also is Google uses these retinal scans to detect diabetic retinopathy. And they're also, I think, extending that to detecting cardiovascular health risks just by retinal scans. But a company like Google can do it because they have the resources. But if there are entrepreneurs in the healthcare segment, is there any platform that they can access? Like, does Google have a platform in AI, or does any other company provide that to kind of give a data set and try to draw some conclusions out of it?
Yeah, that's a good question. I don't know of any like platforms. I think this is actually ironically, this is kind of what we were trying to do with the startup that we built. But I don't know of any platforms that kind of allow for that exchange. I think like if you have a company or you have a data set, I think I don't know, as a believer in the power of cold emailing, like I would try to go find researchers that are working in kind of the space that you're interested in and reach out to them and see if they want to collaborate on something, because they probably want interesting data. You just want to explore kind of how things would work or whatever. I think when it comes to collaborating with researchers, especially like at places like MIT or whatever, there's always the issue of like intellectual property and all of that. So those are things that you kind of have to figure out if you were to go down that route. But I think in general, like there's definitely no shortage of people that want to work on interesting problems, and there's interesting data sets out there. So I think it's right now I don't know if there's a marketplace really that kind of solves that problem, but I think you can go make your own marketplace and maybe find people to reach out to. Yeah.
Cool. Thanks.
Yeah.
Any more questions, guys?
Hi, am I audible?
Yeah, you're audible.
Yeah, I think my internet is a bit unstable right now, but so I would like to just thank Nabeel for his time and the wonderful and inspirational webinar. We especially liked your journey from high school till MIT and also at MIT, and your journey as an entrepreneur. And thank you for asking the questions on answering the questions on healthcare, architect, and jobs relating to AI. Thank you so much, Nabeel and attendees, for your time. And we would like to see you again, Nabeel.
Yes. Thank you very much, and feel free to reach out. I mean, feel free to share my contact information if anybody wants to reach out and talk about anything further. I'm happy to. So thank you all for your time. Thanks for joining. Thanks for the opportunity.
Thank you so
much, Nabeel.
Thank you so much.
Thank you so much.
Bye.
Bye-bye.
Bye.
Thanks.